Hello everyone, we are going to do section 10.1, which is only one section in chapter 10, nth roots and rational exponents. First, we're going to talk a little bit about roots, how they define. So, well, everyone is familiar with a square root, which is like square root of 4 equals 2, right? Or a cubic root of 8 equals 2 as well. Define root. Nth root is going to be a number which you raise to the power of n, and you number b. So nth root of some number a is going to be the number b, which you raise to the power of n and get a back. We are going to call this root a principal root. Remember from complex number sections that actually there are nth roots. We are going to consider only one. Okay, and that's going to be like a principal root. You raise it to the power of n and get back your number 8. Okay, for even n, like 2, 4, like a square root, a fourth root, sixth root, both a and b must be positive. And for odd numbers n, like 3, 5, so it's cubic root, fifth root, n, a and b can be any. Okay, so can be either both negative or both positive. We're going to set up simple examples. I'm going to start with example number 1. Example number 1. And I'm going to just take a cubic root of 8. Cubic root of 8 equals 2. Everyone knows this, and that's going to be a principal root, right? Next one is going to be a cubic root of 64. So what is cubic root of 64? Well, what we can do, guys, we can try to see like 64. That's a cubic cube of what number? Let's multiply number 4 3 times. You are going to get 64 because 4 2 times it's 16, and one more time is going to be 64. So we are trying to extract a cubic root out of cube of 4. Well, of course, we are going to get 4. So 4 to the power of 3 is going to give us 64. Okay, if we do have a cubic root of negative 64, cubic root of negative 64, sorry, sometimes I don't press enough. We're going to get negative 4 because we multiply negative 4 3 times, we get 64, and minus 3 times is going to give us a minus, so it's going to be negative 64. Next one is a square root of negative 2 squared. Wow, a tricky question, right? What is going to be the result? Well, imagine that you take negative 2 and square it first. You're going to get 4. We do know already that square root of 4 equals 2, right? So how, well, it's not exactly negative 2, which is supposed to be if you just cancel square root and the square. So we are going to write down that a square root of number, if you have positive index, if you have even index over here, is going to be absolute value of this number. And this way we are actually going to get 2, not negative 2. Okay, just remember that if you have even power, and here index is going to be on always positive number, right? I'm going to write down a general rule we're supposed to have. So general rule. If n is odd, then the nth root of a to the power of n is going to be just a. If n is even, then nth root of a to the power of n is going to be absolute value of a. So if you have a negative number here, eventually it's going to become positive because of even power, like 2 or 4 or 6. And then when you extract the root, you are going to get a positive number at the end. Okay, a little bit more rules about roots you probably already kind of remember. Let's say call it more rules. Well, so let's start with root product of a and b. Roots are kind of going to be distributed over both factors. So it's going to be nth root of a multiplied by nth root of b. Well, example, a cubic root of 4 multiplied by 7. It's a cubic root of 4 multiplied by a cubic root of 7. You're not going to have any benefit from this one because neither 4 or 7 are cubes of anything. But in generally, you can probably extract a cubic root if you consider one factor. Same is going to work for fractions. If you do have a fraction a over b, you can distribute a root over numerator and denominator. Square root of a and a square nth root of a and nth root of b. Well, for example, a square root of 1 over 4 is going to be a square root of 1 and the square root of 4. We do know that square root of 1 equals to 1 and square root of 4 equals 2. So our answer is 1/2. Well, what is going to happen if you have an nth root of a to the power of m? For example, m is not same as n, different number. For example, this is 2 and this is 5, or opposite, this is 3 and this is 2. How it's going to work? Well, first we can exchange the power and the root. So here we take a, raise it to the power of m, and over here then extract nth root of the result. We can do first extracting a root and then raise it to the power of m, and it's still going to work same way. Well, let me show you an example of this. For example, I'm using mostly books examples, so if something is not clear in my writings, you can always look up how it looks in the book. I'm going to simplify next expression. Fourth root out of 16 multiplied by x to the power of 5 and divided by 81. I'm going to apply rule number rule number 2 to fraction. I'm going to extract the fourth root of 16 multiplied by x to the power of 5 and divided by fourth root of 81. I'm going to recall that 16 at 2 to the power of 4, right? And x to the power of 5 can be represented as x to the power of 4 by x. I'm going to use it in future. In denominator, fourth root and 81, it's actually fourth power of 3. 81 is 9 by 9, and 9 is a square of 3, right? Now I'm going to apply rule number 1 to this expression. I'm going to extract fourth root from here, and from here. So fourth root of 2 to the power of 4, and the fourth root of x to the power of 4, and the fourth root of x. And in denominator, I have a fourth root of 3 to the power of 4. Well, by one of the first rules, when you have fourth root and the power of 4, we are going to cancel the roots, and if the number is negative, we are going to use positive number, right? Well, here we do have everything positive, so we don't need even bother about this. Here, well, we don't know actually what x is going to be because x is a variable. We don't know whether it's positive or negative. So I'm going to put absolute value of x, again, because I'm extracting even root. For this one, I'm just going to keep it. There is nothing I can do about it. And for denominator, I'm going to cancel 4 and 4 here and get 3. And that's going to be my final answer. Okay. Well, what else we can do with roots, and also we call them radicals? Well, we can kind of simplify expressions which have radicals. Simplify. For example, I'm going to consider something very simple example, but you can kind of use homework questions for more complicated examples. 2 cubic roots of 5 plus 3 cubic roots of 5. Well, how do we simplify this expression? Well, I see that cubic root of 5 is the same factor here and here, right? I'm going to take it outside of parentheses. What is going to be left in parentheses? 2 from this term and 3 from the second term, which I'm going to add, get 5, and put this 5 in front. Usually, guys, we like to write down roots at the very last expression. So it's 5 cubic roots of 5. Okay. Well, what else we can do with roots and simplifying? We can rationalize denominator. Rationalize rationalize denominator. There are several different ways to do it. Well, first one, we're going to rationalize numerical denominator. For example, we have a cubic root, a square root of 3, and the 4 divided over square root of 3. To rationalize denominator is to eliminate the root from denominator, have just a number. It does not mean that you're going to eliminate everything from denominator or denominator itself. No, but just like have all roots in numerator. Well, I'm going to multiply my fraction in numerator and denominator by something which is going to turn the square root of 3 into just a number. Well, suggestion is to multiply it by square root of 3 in both numerator and denominator. How it's going to help us? In numerator, we have 4 square roots of 3. In denominator, we're going to have square root of 3 and square root of 3. So it's like square root of 3 squared. We do remember that when we square a square root of 3, we can kind of exchange power and the root, right, and get a square root of 3 squared. Well, and now we can cancel root and the power and just get 3, right? So my answer is a 4 square root of 3 over 3. You see that denominator is still present here. The only thing we did with denominator is rationalize it, make it like a normal number, not a square root, okay? Well, next example is going to be rationalize something more complicated. What if your denominator is not a square root, but something like a cubic root? By what we'll need to multiply it? Well, you remember the idea here was to cancel actually, like have a second power of this cubic root, square root, and the square root. So 2 and 2 here cancels. Here we do have 3. So it's not going to be just enough for us to multiply it by a cubic root of 3 and cubic root of 3 here, because 2 cubic roots of 3 are going to give me 9. So cubic root of 9 is nothing, right? So I'm actually going to multiply by 2 cubic roots of 3, 2 cubic roots of 3. This way, I have 3 cubic roots, which are going to unify into the cube of this cubic root, which are going to eventually cancel, right? That's cubic root of 3 cubed. They're going to cancel. Here, we're not going to change anything, we're going to unify them together. So I'm going to write down 4, and 3 multiplied by 3 is 9, and in denominator, I just have 3. So when you deal with roots, be careful about index over here. It's a square, you can just multiply by it. But if it's anything else, you will need to think like what is going to be complementary to your expression to turn it into a number like 3, for example, okay? Now, sometimes we'll need to simplify expressions with roots and denominator. I'm going to consider a simple one, but can be anything more complicated. For example, instead of 1 root, you do have a difference of 2 roots. Square root of 2 minus square root of 3. How do we going to turn it into a number? Well, we are going to recall formula 1 from section 8.1 where we had special products. I'm going to multiply this expression by complementary expression, a square root plus square root of 3, square root of 2 plus square root of 3. And the numerator is supposed to be same as square root of 2 plus square root of 3. So why is going to help us? If you recall the formula from section 8.1, that's a minus b, a plus b, it's supposed to be equal a squared minus b squared. How it's helpful? Well, I'm going to copy numerator. Numerator is not going to change, it's going to stay forever like this. But in denominator, I square this, and when I square a square root of 2, I'm going to just get 2, right? And when I square second term, like square root of 3, I'm going to have a square root of 3, which is just 3, right? And my denominator is becoming just a number, and this number is going to be -1. So my final expression is going to be just minus 5 square root of 2 plus square root of 3. And you see, I totally eliminated denominator. Usually it's not going to be the case. You can still have something in denominator, but it's not going to have anything with square roots. Okay, now let's talk about irrational exponents. What are irrational exponents? Well, let's start with definition. A to the power of 1 over n equals nth root of a. So instead of writing down a radical notation with a root and index, right, we convert it into a power notation, and the power is going to be 1 over n. So for example, 4 to the power of 1 over 2, that's actually going to be a square root of 4, which is going to be 2. Right, 8 to the power of 1 over 2 is going to be a square root of 8, which can be represented as a square root of 4 multiplied by 2, or a square root of 4 by square root of 2, which is going to give me 2 square roots of 2, right? And minus 27 to the power of 1 over 2 is going to be a square root of negative 27. Oh, that's not square root, cubic root, let's say, sorry. We cannot extract square root of negative 27, right? I'm going to fix it to cubic root of negative 27, which is going to be minus 3, right? Okay, so now what if we combine together the power and the root, something like this? We write down an nth root of a and raise it to the power of m. Well, the nth root of a, it's a to the power of 1 over n, right? And then the power of m. We remember that we multiply powers when we raise power to the power, and it's going to give us, let me write it down, like 1 over n multiplied by m, and that's going to give us a to the power of m over n. That's going to be like what we use for definition. So actually, this expression, which is a rational exponent, rational number here, is going to be converted into a root and power. Well, of course, there are some restrictions on a. For example, if you want to extract a square root, you want to have something positive under the square root or a fourth root. But otherwise, that's how we kind of use it. So several examples. Let's move definition up, several examples. Example number 1. Imagine that we want to have 9 to the power of 3 over 2. What is going to be? Well, you can write it down as a square root of 9 raised to the power of 3. Square root of 9 is 3, raised to the power of 3 is 27, right? Or you can do it like 9 cubed and then extract a square root. 9 cubed is 729, and the cubic square root of this number is still 27. But first way is easier, right? Here you need a calculator to cube 9. Okay, next example is 32 to the power of negative 2 over 5. Here, guys, I'm going to first kind of deal with minus. Remember that minus in front of the power means that actually number was in denominator. So I'm going to write down 1 over 32 to the power of 2 over 5. Now, I'm going to use my rule about rational exponent. So I'm going to first write down the root, 5th root of 32, and then choose the power of 2. Well, if you don't know, just 2. You multiply 2 5 times, you're going to get 32. So I'm going to get 1 over 2 squared here, or 1 over 4. Easy to simplify. You can have similar questions in your homework. Okay. Last topic we are covering in this section is rational equations. What if your equation has a radical or something like a cubic root, square root, or something like this? Let me push this up and just kind of separate this topic. So radical equations. I'm going to just consider example of radical equations. 2x minus 4 cubic root Sorry, too early. Minus 2 equals 0. How do we solve radical equations? The best way to solve it, to isolate the root on one side of equation and everything else on another side of equation. Then eliminate the root by raising to a certain power. For example, here as a cubic root, if you raise it to the power of 3, it's going to disappear, right? So I'm going to start with step 1. I'm going to isolate the root. So I'm going to move this 2 to the right side. Now I'm going to eliminate the root. So I'm going to raise this cubic root of 2x minus 4 to cube. Remember to not change equation. I have to raise the right side to the cube too, right? Here, cube and cubic root cancel each other, and I have 2x minus 4. And here it's going to be 8, right? So we are going to have 2x, and I move 4 to the right side. I'm going to get 12, from where my x is going to be equal 6. Usually, guys, when you use raising to the power, it always makes sense to check if your solution actually solves initial equation. Okay, so I'm going to do it by just plugging in 6 into plugging in 6 into my equation. So it's a cubic root 2 multiplied by 6 minus 4 minus 2. Is it going to be a true statement? Is it equal to 0? 2 multiplied by 6 is 12. 12 minus 4 is going to give me 8, right? So I have cubic root of 8 minus 2 equals 0. Is it actually equal? Well, that's equal to 2. 2 minus 2 equals 0. So we did the check. I'm going to label check. Sorry, not very nice to write down on computer screen. Okay, so now what I want you to do, guys, I'm going to give you an equation to solve on your own, and I want you to do the check actually. Maybe it's going to still work anyway, but so that's going to be self-work. For self-work, I'm asking you to solve equation a square root of 12 minus x equals 4. Here you don't need to isolate anything, it's already isolated. So x is isolated from the square root. You just need to square both sides, find the root, and check it back if it's actually the root. So I'm going to count to 5 and then solve it myself. So 1, 2, 3, 4, 5. So I'm going to start solving it. So because it's the root is isolated already, I'm going to just square both sides. 12 minus x, and I'm going to square it. Then right side is going to be squared too. So here square and square root cancel each other, and I'm going to get normal quadratic equation, right? That's going to turn into x squared plus x. I'm moving this minus x to my right side, and minus 12 equals 0. So to solve this equation, I can probably factor it. Let's factor it. That's x. Well, we have 3 and 4 here, right? I think it's minus 3 and x plus 4 equals to 0. Let's check it. Minus 3 by 4 is minus 12. And 4x minus 3x is 1. Okay, so solutions are x equals 3 and x equals negative 4. Let's check both of them by plugging in back into original equation. So let's plug in 3 here. So check for 3. 12 minus 3 is going to give me a square root of what? Square root of 8. Oh, square root of 9, sorry. 12 minus 3 is going to give me the square root of 9, which is going to be equal to actually 3 if I plug it in over here. So checks. How about negative 4? I'm going to put it here, the check. 12 minus negative 4 equals negative 4. Well, let's combine this together, minus minus plus, so it's a square root of 16 equals negative 4. Well, generally speaking, somewhere like where we can extract like the square root, we don't know like 16 was a square of 4 or negative 4, right? But In this section, we are dealing only with principal roots. Principal roots for even powers are always positive numbers. So this one does not check because the square root of 16 cannot be negative 4. It must be 4. Okay. Well, again, this happens because we are dealing only with principal roots in this section. Okay, so we did check everything and we got this extra solution because we were raising to the second power. Now, solution is going to be only 1 and x equals 3. That's a solution. I'm going to box it. Okay, that's all in this section. I want you to do the homework, and that was the last section we cover. And I think that I'm going to put a review sheet for the final exam as my next step as soon as I prepare it. I'm planning to use about like 30 questions in this review sheet. And what I want you to do, guys, maybe you pick up a question, solve it for me. Let me check it and make a little video of this solution. Instead of me doing the video, I want to collect videos from people in class and post it as examples of solutions so you can have a chance to see each other maybe one more time in this semester. And thank you very much, and do the homework, okay?